Welcome to the Bounce Lab. In this lab, we'll explore the concepts of momentum, impulse, change in momentum, and compare the effects of objects that bounce versus objects that don't bounce. For this lab, the materials that you need will be a block of wood, a bouncy ball with a string attached, a koosh ball with the same length of string attached, and something to hang them from. The mass of the koosh ball and the bouncy ball are going to be the same. What we're going to be doing in the Bounce Lab, we're going to be swinging these different objects into the block of wood to see these effects. The first object we're going to test is the koosh ball. We're going to lift the koosh ball until the string is parallel with the table, then swing the koosh ball into the block of wood. Now we're going to take that bouncy ball and swing it into the block of wood. I'm going to lift the bouncy ball until the string is once again parallel with the table. Let's take a look at that again. Notice when the koosh ball hits the block of wood, it doesn't knock the block of wood over. When the bouncy ball hits the block of wood, it does knock the block of wood over. So the big question for this lab was, why was the effect of the same mass of an object hitting the block of wood different? And the only difference was one bounced and one didn't. One of the objects just stopped. The other one bounced off. So which one would have a larger change in velocity? Remember, velocity is a vector quantity, so it does have a direction. One of them just stopped. One of them went in the opposite direction. So now let's talk about change in momentum. Which of these objects had a larger change in momentum? Well, if they had the same mass, what's going to affect it is the change in velocity. Which one of these had a larger change in velocity when it hit this block of wood? So they hit the block of wood going at the same velocity. However, the final velocity for that koosh ball was 0. The final velocity for this bouncy ball was in the opposite direction. It was negative, so there's a larger change in velocity for this bouncy ball. Assuming that they're the same mass, this bouncy ball is going to have a larger change in momentum. Even though they have the same mass, it had a larger change in velocity because not only did it stop, but it went a different direction. We know that change in momentum is impulse. When this koosh ball hit this block of wood, it only had to apply that one impulse to slow it down. We know that impulses occur in pairs. Whatever the impulse this block of wood applied to the koosh ball to stop it, this koosh ball also applied to the block of wood. Well, with this bouncy ball, not only did this block of wood have to apply an impulse to stop it, but it also had to apply an impulse to send it the other way. And since we know that impulses always occur in pairs, well, whatever the impulse is that this block of wood applied to the bouncy ball had to apply to this block of wood. So we know that this bouncy ball had a larger change in momentum because not only did it have to stop, but it went the opposite direction, meaning this bouncy ball had a larger impulse. And since impulses occur in pairs, we know that it also had to apply a larger impulse to the block of wood than the koosh ball. That's why the bouncy ball knocked this block of wood over and the koosh ball didn't, even though that they're the same mass and they were swinging with the same velocity when they hit. The bouncy ball underwent a larger change in velocity because it had to bounce backwards and it applied more of an impulse to this block of wood, knocking it over. Once again, this is the Bounce Lab.